Hello everyone, this is Clovis from the Fritzen Lab YouTube channel. Today we're going to talk about digital to analog or DAC converters. They are responsible for converting binary information or information inside microcontrollers to usable information in the world, to analog information. How we're going to do that? So there's a technique called R2R, which uses only resistors. In our case, we're going to use 6 GPIO or 6 output pins of a microcontroller. The ESP32 in my case, and 12 resistors of 10K and 4.7K ohms values to generate analog voltages between 0 and 3.3 volts. Let's see. So guys, first thing I want to show you the schematic diagram so that we can understand what we are doing in here. So this is a ESP32C3, as I said. It's in a board I made myself. There's a potentiometer, a 10K potentiometer in the analog input A0 going into the microcontroller. This information is processed and then it's converted into binary for 6 bits. These 6 bits in here depend on the value of the potentiometer. So this is applied to the R2R network, which consists in 6 10K resistors and 5 4.7K resistors, and then they generate from the binary number in here, they generate an analog input based on the value of the potentiometer. This LED in here is just here for blinking, just for show. I have not mentioned before, but this code was made in Arduino, specifically Arduino IDE 2.3.8. This if in here blinks the LED every 200 milliseconds, and then this if every 100 milliseconds does the analog read to raw analog value, and then shifts those 12 bits to only 6. It effectively converts from 12 to 6 bits, and then those 6 bits are enter this for loop, and then they are written to the digital pin corresponding. Okay, let's look at that in practice. So as I said before, I have a potentiometer in here in the analog input of the ESP32C3. This is the LED blinking here. We're measuring 2.77 volts at the output of the resistors. Let me turn the potentiometer. I'm gonna go up. It goes 3.15, around that, and that's because of the value of the resistors. They're all 5% tolerance, so this is never going to get to 3.3, okay? Now let me go down. I'm going down, 2.7, 2.4, 1.6, 0.9, finally 0. So effectively turning the potentiometer alters the digital value applied to the resistors and then alters the analog value present in the output. So guys, as you saw, it is possible to use a couple resistors. In my case, for 6 bits analog output, I use 12 resistors. One microcontroller, it can be any microcontroller really, because every microcontroller has GPIO. This is what microcontrollers do. So you can use any microcontroller for this experiment. You can generate analog voltages at 6 bits, 8 bits, 12 bits even. If you put enough resistors, you can even go to like 16 bits analog output, okay? You can generate any voltage using this resistor cascade in one microcontroller. For more information about this, go to fritzenlab.net. Again, fritzenlab.net. See you guys in the next few videos.